Hi everyone. In this video, we are going to learn trigonometric identities. I'm sure you must be aware that in Trigo, identities is a very important topic, right? It is like for the 8th chapter, that is the first chapter of Trigo, the identities play more than 50% of the role. Okay. And अभी तक लास्ट ईयर के बच्चे बड़े सीनियर्स जो होते हैं आपके वो हमेशा डरा देते हैं यार ट्रिगो बहुत डिफिकल्ट है, ट्रिगो ऐसी है, ट्रिगो वैसी है. बट बिलीव मी, ट्रिगो बिल्कुल भी डिफिकल्ट नहीं है अगर उसको हम ठीक से समझें. राइट. सो लेट्स लर्न आइडेंटिटीज. पहले हम देखेंगे इस वीडियो में दैट हाउ दे आर एक्चुअली डिराइव्ड, बिकॉज डेरिवेशन बोर्ड्स में नहीं आएगी, लेकिन डेरिवेशन को समझना इट हेल्प्स टू एक्चुअली रिमेंबर दैट हाँ ये आइडेंटिटी इस तरह से एग्जिस्ट करती है और इसलिए एग्जिस्ट करती है. राइट. और उसके बाद we will be doing 4 examples from NCERT which are given in the book for identities. Okay, so let's start doing them. First, we will talk about identities. What are they and how do we get that? Over here on the screen, you can see a right angle triangle, right? A right angle triangle that B. Now, according to Pythagoras theorem, what we have is AB square plus BC square equals AC square, right? Now, over here, I'm dividing both sides by AC square. That is, I'm dividing by hypotenuse. So what we get? AB square by AC square plus BC square by AC square equals AC square by AC square. Now, let's consider this is the point where we have our angle theta. Okay. So, अब इस theta के according AB by AC, I can write it as AB by AC whole square also. Right. And then I can write it as BC by AC whole square. On the right side, AC square by AC square gives us 1. So, AB by AC क्या देता है? What is AB by AC over here? That is P by H. BC is your base. Before I say, I'm giving 1 second break. Quickly think in your mind, what is P by H? What is B by H? Okay. Okay. P by H is sin theta. So sin theta whole square plus cos theta whole square equals 1. Now it can be rewritten as sin square theta plus cos square theta equals 1. And this makes your first identity. Do remember, this is your first identity, sin square theta plus cos square theta equals to 1. और कुछ नहीं किया हमने, we just used Pythagoras theorem, divided it with the hypotenuse and we got that. Okay. अब इस आइडेंटिटी को इस तरह से तो लर्न करना ही करना है, लेकिन along with that, there are 2 more forms which you need to remember. Okay. And the forms are sin square theta equals 1 minus cos square theta. What I did, I just took cos square theta on the right hand side. And similarly, I can write cos square theta also equals to 1 minus sin square theta. ये तीनों फॉर्म्स जो हैं फर्स्ट आइडेंटिटी की ही हैं, right? There are total 3 identities in your curriculum and I have just written 3 ways from the first identity. Now, let's move on to the second. Second में भी हम वही करेंगे. We have AB square plus BC square equals AC square from the right angle triangle, right? पहले हमने किससे डिवाइड किया था? हमने AC square से डिवाइड किया था. अब हम किससे डिवाइड करेंगे? अब हम डिवाइड करेंगे divide by BC square. Okay, BC square से डिवाइड करने से क्या मिलेगा? AB by BC whole square plus BC square by BC square, that is 1. AC by BC whole square. Okay, AB by BC क्या था? देखो फिगर. AB by BC is P by H. P by H P by B. P by B क्या होता है? That is tan theta. So tan square theta plus 1 equals AC by BC means what we have? Hypotenuse over base. Hypotenuse over base is nothing but sec theta. So here we have sec square theta. And this is your second identity. Okay, tan square theta plus 1 equals sec square theta. Now, the way I had written two forms from the first identity, I will be telling you two more forms from the second identity also. We can rewrite this as tan square theta equals sec square theta minus 1, or we can write 1 equals sec square theta minus tan square theta. What I'm doing, I'm just shifting things left or right. So there are other versions also possible, whatever you shift, but the core identity remains same. That is tan square theta plus 1 equals sec square theta. Now, in this one, we had divided by BC square. In the first one, we had divided by AC square. Now, we will divide by AB square. Okay, so what do we get? AB square by AB square gives us 1. BC by AB whole square equals AC by AB. Right? So now what do we get? We have 1 plus BC by AB. According to the figure, BC by AB. BC is your base, AB is your height. Base by height क्या देता है? That is cot theta. Right? So what we have is 1 plus cot square theta. And on the right side, we have AC by AB. AC by AB. AC means hypotenuse, AB means perpendicular. So hypotenuse over perpendicular is cosec theta, right? It is the reciprocal of sine. So it is cosec square theta. And this is your third identity. This is your third identity. And now similarly, we can rewrite this as 1 equals cosec square theta minus cot square theta, right? Or we can write cot square theta equals cosec square theta minus 1. So, abhi tak we just learned that how these identities have been drafted, have been formed from a right angle triangle, and what are the different ways to write one single identity. Okay, now let's start doing the questions. The first one is an example 9 from NCERT, which says express the ratios cos A, tan A, sec A in terms of sin A. Now, when we are using the identities, we don't need to make a right angle triangle. Okay, so I'll just do it without the right angle triangle, without any Pythagoras theorem now. They have asked to write cos, tan, sec in terms of sin. The first one, cos square theta, we know from the first identity, can be written as 1 minus sin square theta. Oh, I should be using A over here. Guys, this is the kind of mistake that happened. In the question, they have used A instead of any other angle. So while writing the working, we should be using the same angle, otherwise you will lose marks. So over here, cos square A equals 1 minus sin square A. So what do we get now? We will just do the square root on the other side, and that is square root of 1 minus sin square A. In the question, they had asked cos A, not cos square. Okay. Second part, they want tan. Tan A equals sin A over cos A, right? We have to write this in the form of sine. So sin A in the numerator remains as it is. But cos A can be rewritten as under root of 1 minus sin square A. And hence, this is your tan A in terms of sine. So basically, हमें करना क्या है? किसी भी ratio को we have to convert things in such a manner that you just see sine only on the other side. Okay. The last they had asked on the question was sec A. Now, what is sec A? Sec A is reciprocal of cos. I can write as 1 over cos A. And now we have already converted cos in terms of sine. So it means 1 over square root of 1 minus sin square A. This was the first example for the identity-based questions. However, it is example 9 from the whole chapter 8. Okay, let's start with the next one. Example 10. Prove that sec A into 1 minus sin A into sec A plus tan A equals 1. Now, what do we do over here? Okay, guys, two thumb rules for identity-based questions. First, whenever we are proving, this is a proving question, there are two sides, LHS and RHS. Okay, in 99% of the questions, you will just be solving LHS to bring it equal or at par with RHS. मतलब हम सिर्फ लेफ्ट हैंड साइड सॉल्व करेंगे और वो ऑटोमेटिकली हमें राइट हैंड साइड की वैल्यू या आंसर दे देगा. ओके, दिस वाज योर फर्स्ट रूल. सेकंड रूल, generally हम 99% again, I'm not saying always, I'm saying 99% of the times, we will end up converting all other ratios in terms of sine and cos. अब sec है, I will write 1 by cos. Tan है, I will write sine by cos. So this way, in majority of the questions, you will be converting all other ratios in terms of sine and cos. Okay, coming back to rule 1, I said that we always solve LHS, but 99%. There are few cases where you will be solving LHS, you will be solving RHS. And how do you realize कि LHS solve करना है कि RHS? देखो, start हमेशा LHS से होगा, right? LHS से start करके अगर आपको लग रहा है कि आपने पूरा इतना simplify कर दिया है कि अब और कुछ नहीं हो सकता, there is no other option left, then in that case you will start working on the right hand side. So you will solve that also such that both LHS and RHS come to a common answer. So that is another way to solve these identity-based questions. Okay, now let's start solving it. It is one of the easiest ones, and just see how do I do it. Sec can be written as 1 by cos A. Okay, in bracket we will leave 1 minus sine A as it is. In the second bracket, again sec A, which is 1 by cos A. And tan can be written as sine A by cos A. Now I'm proving it. Okay, I'm not going to bring both the sides together. I'm just solving LHS as of now. So what do we get? This is a fraction. First we have 1 over cos A, which needs to be multiplied. So I'm going to give the second bracket, that is 1 minus sine A, the denominator of cos A from here, right? So I get 1 minus sine A over cos A. I can write like this. In the second bracket, we have same denominator of both the terms. So I'm just adding the numerator, which comes out to be 1 plus sine A whole over cos A. Now we can see we have got two brackets. Guys, in identity-based questions, you will see the identity of A square minus B square very frequently. Okay, and this is what is going to use over here also in numerator. This is your A minus B. This is your A plus B. So what do we get? A square minus B square, right? I have 1 as A square and sine square A as a B square. Denominators will also get multiplied. Cos A into cos A gives me cos square A. Now, 1 square is 1. And what is 1 minus sine square A? We had learned from the first identity that it is cos square A. So I'm writing cos square A over cos square A, and it comes out to be 1, which is equals to 1. We had to prove over here, right? Therefore, LHS equals RHS, and in identity-based questions, do write at the bottom, hence proved. Okay, so this was the example 10. Now, starting with example 11. What do we have over here? Prove that cot A minus cos A over cot A plus cos A equals cosec A minus 1 and cosec A plus 1. Let's start with it. I'm going to convert cot in terms of sine and cos. So what is cot A? Tell me. Cot A is cos A over sine A. Okay? Minus cos A over cos A over sine A plus cos A. What I can see, I have got cos A as a common factor in numerator and denominator also. So I'm going to take that out. It comes out. I'm left with 1 by sin A minus 1 over cos A 1 by sin A plus 1. So this cos A and cos A got cancelled, right? Now what is 1 by sin A? That is cosec A minus 1 over cosec A plus 1. And if you see, we just ended the question. We have proved equal to the right hand side. So I will just wind up with my question like that. LHS equals RHS, hence proved. Okay. Now, next example 12, and this is the last example of NCERT 8th chapter before you start with the third exercise. Okay, let's start with it. And guys, this is actually a highly important question, very important one. Okay, इस क्वेश्चन का एक और वर्जन एक्सरसाइज में भी एक एग्जिस्ट करता है, but this example is actually very important. There is a condition in this question that prove LHS equals to RHS using the identity sec²θ equals 1 plus tan square theta. मतलब हमें इस क्वेश्चन में यही आइडेंटिटी यूज करनी है if mentioned, and if not, there are other ways also to do it. But over here, I'm going to solve it using this identity. So let's see how. What we have is, on the left, we can see we have sine minus cos. Sine minus cos plus 1 over sine plus cos minus 1. But on the right hand side, we have 1 over sec minus tan. I said before solving the identity based questions that we should be converting everything in sine and cos. And over here, we are already having it. However, this is an exception from that point, because in this question, we are going to convert things in terms of sec and tan. And how do we do that? Divide numerator and denominator by cos theta. Okay. So what we get? I will write each step carefully. Sin theta by cos theta minus cos theta by cos theta plus 1 by cos theta. This is the work that I have done only for the numerator part as of now. Over sin theta over cos theta plus cos theta over cos theta minus 1 over cos theta. Clear? What I did, I just divided each term of the numerator by cos theta and similarly each term of the denominator by cos theta. So what do we get? Sin theta by cos theta gives us tan theta. Cos theta by cos theta gives us 1. 1 by cos theta gives us sec theta. Now, similarly in the denominator, sin by cos gives tan theta. Cos by cos gives 1. And last 1 by cos gives sec. This is what we get. So, अभी तक हमने क्या किया है? हमने अपने sin थीटा और cos थीटा वाले क्वेश्चन को sec थीटा और tan थीटा के टर्म्स में कन्वर्ट किया, right? Now, over here, what I'm going to do, I'm going to multiply and divide with tan theta minus sec theta. Tan theta minus sec theta यहाँ पे exist करता है, right? उसी से I am multiplying and dividing. So tan theta minus sec theta. अब हम क्या करेंगे after this step? I'm going to multiply. There is a trinomial in the numerator, the first bracket, and then there is a binomial. I'm going to multiply each term by each term. So let's start doing that. Tan theta into tan theta gives tan square theta, right? Tan theta into sec theta gives me minus tan theta sec theta, right? Then minus 1 into tan theta gives us minus tan theta. Next, minus 1 into minus sec theta gives plus sec theta, right? Then what we have? Sec theta into tan theta, that gives plus sec theta tan theta. And the last, sec² into sec². It gives minus sec²θ. So this is the kind of expansion we have in numerator. But we are not going to multiply anything in the denominator. I will just keep my brackets as it is. उनको संभाल के रखेंगे हम अभी end तक. Because just see होता क्या है. यहाँ पे first bracket remains as it is and second is tan theta minus sec theta. तो हमने इनको संभाल के रखना है, हमने इनको ओपन नहीं करना. Now what can you see over here? This tan theta and sec theta is one positive and one negative. So we cancelled out. What are we left? We are left with 4 terms now. Okay, so I'm going to just copy that thing after elimination of tan theta sec theta on the next page. So what we are left is tan square theta minus tan theta plus sec theta plus sec square theta. That was it? No, it was minus. Okay, so it is minus over here. In denominator, we had tan plus 1 minus sec. Guys, similarly, in your exams, when you flip the pages, do write things carefully on the next page. Okay? This is what we have. Right? Now, second identity that they had also said in the question, and that is sec²θ equals 1 plus tan square theta. Now, what you can see in the numerator, we have tan square minus sec square. So if I do tan square minus sec square, my 1 will go on the other side and sec will go on the other side. That means tan square theta minus sec square theta, I will write it over here. Tan square theta minus sec square theta is actually minus 1. So using this, I have minus 1 in place of tan square minus sec square. Okay. And the remaining 2 terms as it is. Oh, it was not sec square, but it was sec theta. Okay. Over, the brackets still remain as it is. I'm sure you must be thinking that why are we actually keeping them? Why are we not solving or doing anything to them? Because now see what we have. 1 tan sec, 1 tan sec. Same terms are we numerator में और denominator की first bracket में. But एक minor difference है. There is a difference of sign in them. मतलब जो positive ऊपर है वो नीचे negative है. तो उसके लिए what we will do? We will take out negative common. Negative common from the numerator. And that leaves me with 1 plus tan theta minus sec theta. And now if you see, it is absolutely same to what we have as the first bracket in denominator. Right? This is what we are left. I am cancelling it out. And this is the reason I just kept my denominator as it is and did not work on it. So now what are we left? Minus 1 over tan theta minus sec theta. Right? I am going to absorb this negative from the numerator in the denominator. So that is going to give me 1 over sec theta minus tan theta. And let's see what the question asked. The question asked the same thing, that is 1 over sec theta minus tan theta, and hence proved. Right? Yeah, I'm just doing the formality now. LHS equals RHS, and at the end you will write hence proved. So in this video, we actually started from scratch for trigonometric identities of class 10th, and we solved all the class 10th 8th chapter identity based examples. I hope you understood everything, and in case you have any doubt, you can always comment below and do hit the like button, and happy learning.